Now, today's topic is ammeter and voltmeter. So today we will learn how to convert a galvanometer into ammeter and voltmeter. First of all, we will see about the ammeter. You know the ammeter from the previous classes. An ammeter is an instrument used to measure electric current in an electric circuit. So an ammeter is actually a modified form of galvanometer. If a galvanometer is used to measure the amount of current flowing in the current circuit, then two things may happen. First, large resistance of the galvanometer in series with the circuit will change the electric current. And second, large amount of current in the circuit may damage or burn the galvanometer. Thus, galvanometer cannot be used to measure in the circuit. For measuring current in the circuit, we require a device of very low or practically zero resistance. Moreover, this device may measure even large amount of current. Thus, a galvanometer has to be converted into a device which may fulfill all the conditions said before. Such a device is known as an ammeter. Now we will learn how to convert a galvanometer into an ammeter. So here we will see the conversion of galvanometer into ammeter. A galvanometer can be converted in an ammeter by connecting a low resistance which is known as the shunt. So shunt should be of low resistance parallel to the galvanometer. We will see here, this is the galvanometer and a resistance of low resistance. A resistor of low resistance shunt is connected to the parallel here. Now G is also the resistance of the galvanometer and S is the resistance of the shunt. Now let I current flowing through the galvanometer, or you may say the total I is the total current to be measured in the circuit. So suppose Ig is the magnitude of the current flowing through the galvanometer. So current flowing through this shunt will be I minus Ig. One more thing, we will see G and S are parallel. So potential difference across this and across this will be same. So we will write potential here now, potential across this galvanometer, that will be Ig into G, then potential difference across this resistance, that current I minus Ig into its resistance. Here we will be using the Ohm's law, V equals to IR. So value of S, that will be equals to IgG by I minus Ig. So this is a required value of shunt. This is the required value of shunt resistance to convert a galvanometer into an ammeter, which range is 0 to I. This ampere. Now, effective resistance of an ammeter. Here we will see R effective is the effective resistance of the galvanometer. Since G and S are parallel to each other, so 1 by R effective, this will be equals to 1 by G plus 1 by S. This equals to GS and G plus S. So R effective is equals to GS by G plus S. Now, shunt is of very small resistance. So we will see G is too much greater than S. So here we will say that G plus S is near about the value of G, because S is of very small resistance. So from here R effective, this will be equals to GS by G, and this equals to S. So R effective of a galvanometer is very small. So thus an ammeter is a low resistance device. So we can say theoretically resistance of an ideal ammeter is 0. Now we are moving towards voltmeter. Voltmeter. You know about the voltmeter from previous classes. So a voltmeter is an instrument used to measure the potential difference across the two ends of a electric element of a circuit. A voltmeter is always connected in parallel to measure potential difference across the two ends of a electric element in the circuit. If we connect a simple galvanometer in parallel to the circuit, it will draw some current, and hence the potential difference of the circuit will change and the measured value will be not accurate. So for accurate measurement of the potential difference, it is essential that the current between the 2 points of the conductor should remain same after connecting the measuring device of the 2 points. This is possible if the resistance of device is very high or infinite, so that it may not draw any current. A galvanometer is to be converted into a device whose resistance is very high, and such device is known as voltmeter. Now we will learn how to convert a galvanometer into voltmeter. This is the galvanometer. G is the resistance of the galvanometer, and a high resistance is connected to this galvanometer in series, which resistance is R. Now suppose some current flows through this, and that current also flows through the galvanometer because the G and R in series. So let this current will be Ig, and potential difference between these two is suppose V. Potential difference is V across the combination of galvanometer and resistance. So we will say Ig be the Ig be the current flowing in the circuit, corresponding to which the voltmeter gives us full deflection. Then value of V, that will be equals to sum of the voltage across this and sum of the voltage across this. So sum of the voltage across this is equals to IGR plus across this will be IGG. Here Ig can be taken as the common, then R plus G. Now we are going to find out value of R, this R. So this will be equals to R plus G equals to V by Ig, and R is equals to V by Ig minus G. So this is the value of the required value of the resistance, which must be connected in series to the galvanometer to convert a galvanometer into a voltage of range 0 to V volt. This is the range. Now we are going to find out the effective resistance of the galvanometer. So effective resistance is suppose R dash. These two are in series, so we can write R plus G. This is the effective resistance, and this R is too much high, so value of R plus G, that will be also very high. So a voltmeter is a high resistance device, and practically theoretically we can say that resistance of an ideal voltmeter is infinite. Thank you.